notations. So quantum mechanical state होती है अपनी दो होती है. We have two quantum mechanical states termed as Kate and Bra. This form and this form terms as Kate and this form terms as Bra. Okay. Now psi of xt means the wave function is, we say in quantum mechanics, is probability amplitude, or we call it wave function. This is basically probability amplitude psi xt. And how we calculate probability? Basically we do the square of the probability amplitude or wave function. Now the wave function can be written in this form: at x displacement and t time, psi can be defined, and this, and the word bra and ket comes from here, bracket. This is the bracket, bra and ket. So probability of the wave function, finding the wave function at certain point at certain time, will be x t psi square. Now we will try to establish an analogy with respect to our 3D Cartesian coordinate system and Hilbert space. Okay, so in 3D Cartesian coordinate system, we write vector is ax I cap, ay j cap, and z k cap, and here I, j, and k are termed as basis vectors. Okay, similarly in quantum mechanics we use Hilbert space, and in Hilbert space wave function can be as a1 psi 1, a2 psi 2, and a3 psi 3, and here psi 1, psi 2, and psi 3 are terms at basis states. So here a wave function can be represented as linear combination of basic, there are vectors, and here basis are states. Okay, and basis state have certain property, we call it normalization, psi square equal to 1, same as we do ii1 jj and 1 and kk1, and ik is 0, we defined in our Cartesian coordinate system. Similarly here normalized and orthogonal. So when we do normalization here, a1 square plus a square 3 square equal to 1, because psi square is 1. So we say it probability is conserved. When probability is conserved, the constant of the basis state will be square of the constant of the basis vectors will give us 1. So psi can be defined as ai psi I, a1 psi 1, a2 psi 2, and a3 psi 3. And when you interact with another wave function psi 1 to psi, what will psi 1 psi 1, psi 1 psi 2, and psi 1 psi 3, and normalization means psi I equal to 1 and psi ij equal to 0, means del ij can be 0 or 1. So when we applied probability of wave function psi, so probability of wave function psi 1 in the state of psi will be psi 1 psi square will be a1 square, and probability is conserved, so a1 square plus a2 square h square equal to 1, and here a1 is defining as probability of finding psi 1 in psi, probability of finding psi into psi 2, and probability of finding psi into psi 3 state. Here psi 1, psi 2, and psi 3 are 3D state. These are called as complete set of basis state, and we know psi can be defined as a1 psi 1 plus a2 psi 2 is a3 psi 3. These are the set of eigen states. Now we discuss about Hermitian operator, and here Hermitian operator non-resident means a1 is related to only psi 1, a2 related to psi 2, and a3 related to psi 3. So this will be normalized and orthogonal. Now there is certain comparison between linear and Hilbert space. In linear space, basis states are discrete, number of basis states are finite, and expression coefficient are real. In Hilbert space, wave function may be continuous, so basis state may be continuous, and it may be infinite, and it are in the form of complex number, means it can be either imaginary or real. So are these Hermitian? How we define it? Ket of psi equal to Hermitian of bra psi. Bra is defined as row vector and ket is column vector. This is bra and this is ket. So here are certain questions, easily questions. Suppose this is ket, means column and row and column, and here also row and column. So matrix can be multiplied and the product will be 3 cross 3. So this is possible. But here 3 cross 1 and 3 cross 3. So number of column of the first matrix is not equal to number of row of the second matrix, so it's not possible. Here also multiplication is not possible. So what I say, ket and bra multiplication, product of ket and bra can be possible, but product of ket and ket not possible. Product of bra and ket not possible. Bra and bra is not possible. probability of finding psi instead of phi, or probability of finding phi instead of psi. Sorry, we left this. So we understand the interaction of two wave functions. We read it from left to right to left. Okay, here means psi is multiplied on phi, complex number. Psi is interacting with phi, and here phi interacting with psi. Means they are complex numbers. Means if you reverse it, okay, phi and shine, if you reverse it, Bra and Ket form, then it will be complex conjugate of the previous form. Square will be same, so probability is conserved. Now there is a question. 9I cap phi 1 get phi 1 to phi 2, and chi defined minus I2 upon under 2 phi 1 get plus 1 upon 2 phi 2, and it is phi 1 and phi 2 form a complete and orthonormal. Orthonormal basis means phi I is equal to del I, means it can be either 1 or 0. Now we have to calculate Bra Chi and Bra Jai and product of this. So it will be very easy. Just complex conjugate this will be Bra Chi. So just do this. 9 iota minus 9 iota plus 2 get 5 will be phi 2, and this will be reverse, means complex conjugate. This will be iota 1 root 2 Bra phi 1 plus 1 to phi 2. Now we will calculate multiplication of these two, Ket Chi and Bra Chi. So Ket Chi is given to us, and Bra Chi we will calculate it. When you multiply it, this to this, and this to this product. So we are left with minus 9 upon under 2 phi 1 phi 1. It will become orthonormal. So 1 2 upon under 2 phi 2 phi 2 1 phi 1 phi 2 0, and phi 2 phi 1 will be 0. And product of Ket Chi and Bra Chi. So when you do it, phi 1 phi 1 phi 2 phi 2 phi 1 phi 2 and phi 2 phi 1. Okay, just remember phi 1 and phi 1, phi 1 and phi 2, phi 2 phi 1, phi 2 phi 2. So they are not equal to each other. Okay.